بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Welcome to our journey in quality control of ointments and creams. In this journey, we will stop by 6 stations, starting with the concept, validation, impurities guidelines, product quality test, specific test, and performance test. Firstly, we will start with the concept. To start, what is the term semi-solid? Semi-solid is a term used for materials that exhibit plastic-like flowability. A material that is not pourable, does not readily conform to its container at room temperature, and does not flow at low shear stress. The term shear stress is defined as the force that applied parallel to the material, resulting in displacement of the material. Note that the term semi-solid is not used in official article titles in case you decided to look it up. Semi-solid preparations like creams, gels, ointments, pastes, and lotions may be used to apply drug products topically, but topical dosage forms are not limited to semi-solid preparations, since there are topical preparations other than semi-solids like foams, sprays, aerosols, and transdermal delivery systems. Here's a picture showing the percentage of oil to water in some semi-solid preparations like creams, ointments, lotions, and gels, where creams have 50% oil to water, ointment 80% oil to water, and lotion 20% oil to water, and gel 5% oil to water. Topically applied drug products may be used either to achieve local action or to achieve systemic effect after absorption through the skin into the blood. The skin is composed of 3 layers: epidermis, dermis, and hypodermis. The local action may be achieved at the application site, which is stratum corneum, or the underlying tissues, the epidermis and dermis, or in the subcutaneous tissues like muscles and joints. Drug products tests are divided into 2 categories: those that assess general product quality attributes and those that assess product performance. Product quality attributes include the description, identification, assay, impurities, physicochemical properties, and so on. Product performance testing is used to assess the drug release and other attributes that affect drug release from the finished dosage form. And now with emulsions. Emulsions are dispersed colloidal systems that consist of 2 or more immiscible liquid phases, stabilized with 1 or more suitable agent. When the oil phase is dispersed in water, the emulsion is termed oil-in-water emulsion. When the water is dispersed in oil, the emulsion is referred to as water-in-oil emulsion. Emulsions for topical administration are creams, lotions, and sometimes ointment. And there are also oral and parenteral emulsions. Emulsion instability may exhibit 3 types: flocculations, callousness, and creaming. Flocculation happens when the dispersed phase comes out as flakes. Callousness is a progressive forming of large droplets due to the continuous combination of small droplets within the media. Creaming is the migration of one of the phases to the top or to the bottom of the emulsion depending on the relative densities of the phases. Manufacturers commonly add surfactants, pH modifying agents, or emulsifying agents to increase the stability of the emulsion and prevent the previous instabilities and prevent any significant changes with time. Moving to creams. Creams are semi-solid emulsion dosage form, typically contain more than 20% water and volatiles, 50% hydrocarbons, waxes, or polyols as the vehicle. They're generally intended for external application to the skin or to the mucous membrane. They are relatively soft and spreadable and can be formulated as either water-in-oil emulsions or oil-in-water emulsions. They are described as either washable or non-washable owing to the external continuous phase. Aqueous external continuous phases is more easily removed than non-aqueous external phases, aka water-in-oil emulsions. Moving on, we have ointments. Ointments are as creams in the extent that they are intended for external application to the skin or mucous membrane, but ointments contain less than 20% water and volatiles, and more than 50% hydrocarbons, waxes, and polyols as vehicle. Ointment bases fall into 4 general classes: water removal bases, water soluble bases, hydrocarbon bases, and absorption bases. Water removable bases is readily washed from the skin or clothing with water, making them acceptable for cosmetic reasons, and they can be diluted with water, and they favor the absorption of serious discharges in dermatological conditions. Water-soluble bases, known as greaseless ointment bases. They are formulated entirely from water-soluble constituents. Polyethylene glycol is one example of these bases. They offer many of the advantages of the water-removable bases. In addition to that, they contain no water-insoluble substances, and they are more correctly categorized as gels. Adsorption bases. They allow the incorporation of aqueous solutions. Such bases include only anhydrous compounds or water in oil emulsions, and they are useful as emollients. Hydrocarbon bases, known as oleaginous ointment bases. They allow the incorporation of only small amounts of aqueous compounds. Ointments prepared from these bases act as occlusive dressings and provide prolonged contact of the drug substance with the skin, and they are difficult to remove and do not change physical characteristics upon aging. The choice of an ointment base depends on 3 aspects: the action desired, characteristics of the incorporated drug substance, and the drug bioavailability if systemic action is desired. The product stability may require the use of base that is less than ideal in meeting other quality attributes. Drug substances that hydrolyze rapidly, for example, are more stable in hydrocarbon bases than in bases that contain water. Until here, we will end our first episode until we catch up with you guys in the next episode.